Hi everyone, thank you for joining me today. I'll be walking through a quick EDA that I did on this semi-random data set. It's the US Executions Dataset, and so real quick, where I got this data set was from the Death Penalty Information Center. I went here, I actually did not subfilter or subquery this data set. I grabbed all 1529 records, and then all the way down here is just asks me if I needed to download it. I click here, so that's what I did. And that's how I got the data set. So I'll close that out. Um, Real quick, the intent of this video, couple of things. I'm gonna talk to just the things that I did for this data set, and then jump right into the questions that I answered, and then um, additional questions with multiple variables. And we might have a couple of on-topic tangents along the way, but that's okay and that's good. Um, with that said, we'll just get started here. So the first thing was importing libraries and examine data properties. Pretty simple. So the libraries that I was using, um, well, mainly pandas, matplotlib, seaborn, numpy, calendar, and datetime. Um, I didn't use JSON because I wasn't importing the data as a JSON. It's actually a CSV. So I should be able to run this here and it'll work just fine. This piece of code here styles tables with a border. Makes it easier for when I'm outputting data frames for me to read it. So I can show you what it looks like real quick here. So with this on, it just adds a border like so. With this off, it looks like this. So I am a fan of the borders, just makes it easier to follow, and maybe it's just me, but that's the code that I use for that. And I use it pretty much any Jupyter notebook that I start working on. I try to import this code. The first thing, examine data and its properties. So I'm actually just gonna read the data. So I do this pd pandas.read CSV, which is assigned to that df data frame variable. So now I can take a look at the shape of the data frame, and this df.shape just tells me there's 1529 rows as expected and 27 columns. I can take a quick peek at the data doing this df.head with a 5. It basically give me the first 5 rows, and you can see here I get the first 5 rows of the data. By taking a quick peek, it's ultimately just trying to get a feel for what the data looks like. Oftentimes, you can have columns and you may have values within those columns that are maybe not something you anticipated, or there may be a null value like a non. None sounds good right now, actually. But anyways, I digress. So there may be null values as such, and it may be something for a column that shouldn't be null. So it allows you just easily see like, okay, maybe I'll have to work on this specific column in terms of cleaning. Luckily for us, this data set is pretty clean. I mean, I'll show you right here. So the next row is df.isNullAny. So this gives me any columns that have null values as true, and you can see they're all false except for these two columns here. So middle name and suffix, those are the only two that are true, meaning these columns do have null values, and we can validate it up here to say, okay, yes, even the second and third so on have no value, so that makes sense. Also, the column's middle name, I expect that I'm not going to interpolate it and assign a middle name to every record because not everybody has a middle name, and same for suffix. Not everybody has a suffix. Um, so with that, you can do a deeper dive into kind of how many values are missing doing this df.info. This is kind of my favorite to go to in terms of once I have the data imported, I do this df.info to get a view of the columns, tells me what data type. So when it imports the data, it basically assigns it a data type. And so it depends on how the data is coming in, right? So sometimes you'll have a column where it should be an integer because it's, I don't know, I'm thinking like it's a dollar sign, so it's in whole numbers and it has a dollar sign in front of it, and it'll actually treat it as in its string. So you'll need to be aware of that. All that confusion just to say this is what it looks like for this specific data set, um, and the data types for each. One of the interesting things that I like to look at is, so this one says it's 1529 rows, which we already knew, but for every column, it tells me how many are not null. So how many rows have a value of execution number? There's, they all do 1529, so on and so forth. So middle names, there's only 432 records with a middle name and 0 records with a suffix. So this might explain why it's brought in as a float. There's actually no values in this suffix column. Because I was thinking if there were values, it would be like junior, senior, the third, the fourth kind of thing. But it says 0, so that's why the data type is set to float. Anyways, I don't even know why the data set has this column. It seems like it wouldn't be necessary if it doesn't have any values, and we can't even interpolate it. Okay, so moving forward, I did a quick second peek, I guess, of the data set. So this is kind of like double take, like, wait, what? Um, but maybe not like that. Okay. So let's just forget I did that. The next section. So after I take a look at the data set, generally you would clean it. For this one, we're pretty darn lucky. There's nothing to clean really. Everything has a record. You can also look at, let me see here. Like for example, some of the things that I did to make sure that I don't need to clean it, I would go in and I'd say, okay, let's say how many um, how many unique values of race are there? And there's like, okay, so these are the unique values of race. If in the case, let's say there was another value here and it was Latinx, right? So we had Latino and Latinx. In my mind, I'm thinking, well, that's pretty much the same. It might be like just a terminology change from 1977 to now. So I would maybe take a executive decision of, hey, I'm actually going to update anything that says Latinx to say Latino or vice versa. So that would be the type of data cleaning that you would do. If there is some number that you need to interpolate or some dates that need to be fixed or whatnot, then you would go ahead and do that before you jump into the EDA questions. But because this is that's pretty clean, I'm going to jump right in. So some of the questions, basic questions that I had were just considering the data and only this data, what can I potentially answer? And that's not to say like, well, Omar, like you can just go in here and, you can answer that the fourth record is male. I want to get more, I guess, more of a feel what the data looks like, what it contains, the utility of these rows, and once you start asking questions and you start kind of adding on to those questions, like, okay, well now I know this, but what about this? Um, so questions I came up with. When was the first and last execution of the data set? Which state have the highest number of executions? What is the most common first name of the executionees? And that was just the term that I came up with. Um, what were the most popular execution methods? The average number of total victims per executionee? And what is the distribution of race of the executionees? Pretty standard questions. Nothing too crazy in terms of how we're going to find this information out. So with that said, I jumped into the first question. So what was the first and last execution in the data set? I first wanted to convert this execution date and I wanted to make sure that it was the date. So I took it, which was an object data type as we saw above, and I said set this execution date column in the data frame equal to pandas.to date time and convert the existing value in execution date to date time and format it in this format. And then this last part of .dt.to.date is actually to remove the time, right? Because if I convert it just to a date time, it'll give me the date and the time, which would be like 12 midnight, for example, for every day if it doesn't have a time already. So I just want the date, I don't want the time. So I added that piece of code there. So once I ran that, then the next part was to sort the values and get the first date. So this first date is just a variable, and I basically take a look at df execution date min, and then same for the last date, df execution date max. and then I print them out, and that's how I got the answer to this. So the first execution in this data frame or data is 1977, and then the last, well, I should say last. There you go. Easy fix. Is 2020 December 11th. Oh, so just a couple days ago. Well, not a couple, but about a week. About a week ago. Okay. About a week ago. Yeah. So this is fascinating. So it's definitely up to date. Wait, hold up. Okay. There's a site called the marshallproject.org. I'm in no way related to or affiliated with this site, but I found it fascinating and wanted to share it with y'all as a little related on topic tangent. So basically tells you who is the next person scheduled to be executed, which is, yes, so Lisa Montgomery is scheduled to be executed in 20 days, 2 hours, and 31 minutes. Wow, to the minute, Jesus. Um, and then it tells us here December 11th was the latest update from the site where Alfred Bourgeois was the 17th and last person to be executed this year. Um, okay, okay. So you can learn a little bit more about Alfred. Tells you just a case summary. If you're interested, you can do a deeper dive for a consultant term. A dig deep, a more profound dive. I was looking for a synonym for dive, but I digress. So, um, the last execution date was December 11th, 2020, within this data set. The next question, which states have had the highest number of executions? Okay, so I'm trying to hide it, but uh, I think it's no surprise. But anyways, for this one, I just copied the original data frame using this df.copy, and I did a group by with state. So basically, group every state and count how many values for every state there are in this data set using this dot size. There's other dot sort values is just for presentation purposes, just to make sure that I'm looking and sorting the values in descending order. So if I do that and I run the code, it looks like so. So Texas. Okay, Texas be Texing. Okay. Um, Texas followed by Virginia. Mm, not impressed. Virginia, I didn't anticipate actually. Oklahoma, okay, like next door neighbor competition, but they're really falling behind here in terms of executions, which is a good thing. They should stay behind. Um, Texas is just vicious. What the heck is happening? Florida, 99. Missouri. So basically, yeah, just gives me the top. So the top is Texas. That's the answer to this question. But you go down the rabbit hole here, you see California, 13. Federal, not a state, but okay. I mean, this data thinks it's a state. Oh, okay. I mean, now that I think about it, so basically, if it's not an execution done by a state, then it would be a federal execution, like a they were tried in federal court. Not sure how that works, because I'm no expert in the federal court system, but that's what we have here. So we'll take it as that. And you can see there's not 50 states, so that's good. Some states are haven't done any executions, so good for them. Um, okay, the next question. What is the most common first name of the executionees? All right, so this was just actually a random thought by me. It's like, well, what if there is a common first name? Maybe I can just avoid in the future naming any of my kids um, like that, actually, since the precedence. But anyway, so I did a copy and group by first name, same thing as state, just grouped it by first name and did this dot size to count how many times each first name appeared. Um, and that is the answer. So Robert with 69 counts. So out of the 1529, 69 executionees were named Robert. 63 were named John and James. James, Michael, David, William, Will I am. Wow. Um, well, I'm sure it's not Will I am, but William, um, Richard, Joseph, so on and so forth. Ronald McDonald. Okay, no. Anyways, moving forward. Um, so with this, it's pretty simple to get like the last names. So if I wanted to get the count of last names, you see Johnson's the most popular name. Um, Robert Johnson, not that, that's the thing. But anyways, then you can get the middle name. You can see Lee is a, wow, very popular middle name in executionese. Is that the most popular middle name? Okay, so um, I I googled this real quick. Um, so this is fox8.com. Take that as a reliable source as you may, but I'm gonna stroll through this here. Um, top 10 middle names of every decade. So Lee is a pretty popular middle name, which aligns with what we have here. Lee, followed by Wayne Ray. So Wayne Ray, and this is from the 1940s. Um, and then 1950s, Lee, Wayne, Ray. 1960s there. Oh, I think that's 1960s male. Lee, Wayne, Ray for a lot of the picture here, but okay. 70s, Lee. Lee is losing track. Okay, so there's Lee. Oh, Lee actually male, female. That makes sense. Wayne, number 10. Lee, back up in popularity. No Wayne and no Ray. Lee. Lee is losing. Okay, so I guess Lee is the most popular, or is in the top 10 list of middle names. So um, that aligns, but I would not have expected that. Is this a Lee as well, or just L? Oh well, that was interesting. So back on track. Um, back on track. The next question: what are the most popular execution methods? Pretty similar. Did a group by execution method and just seeing what the most popular are. Okay, so this makes sense. I anticipated. Lethal injection would be the most popular. Electrocution 163, gas. Okay. Hanging and firing. Firing squad and hanging. So I wanted to dig deeper and say, hey, what's going on with, give me all the records where hanging is the execution method, and here they are. See, and it's not 1977, so 1996 is the latest one that was hanging in Delaware. Is that fascinating? Okay. Um, Firing Squad. 2010 was the latest one. Um, all in Utah. Utah, the firing squad friendly state. Is that their slogan? Okay. So, quick, what the heck was that? Okay, so we're going to take a quick related deviation. Staying on topic, but Utah is the beehive state. That's the moniker. I did not know this, but now I do. And the reason, just a quick Google search, is the original title was State of Desiree, and Desiree meaning honeybee in the Book of Mormon, which makes sense. And then there was a statement saying that there is a beehive, which now I see it, in that state of Utah seal, which makes some sense as to why it's a beehive state, but no sense as to why it continues to be a beehive state. But I'll take it at face value and just say Utah is the beehive state, but in executions, it's the firing squad friendly state. Um, so actually, let's take a look at how many do they have. I mean, if they have 7 executions, but 3 of them are by firing squad. Well, that's enough to say you're the firing squad state, and not for a good reason. So, moving forward, the next one, average number of total victims per execution E. This one was a blunder from my part because it's pretty easy in terms of just getting the real answer to this. So basically, if I just took the number of victims and took the mean, I get the average number, which oh, I need to first create this DF copy. I get the average number of 1.61. But then I thought, well, maybe I can just separate it further and say, is there a difference between the number of victims and the execution method? Short answer is, I don't think there's enough data to tell, but from this data set, hanging has the highest number of average of victims. So those executionees who were executed via the hanging method had about 2.6, 2.5 people. It doesn't make sense, but anyways, as such, and then gas and so on and so forth. The firing squad, funny enough, or interestingly enough, more so, only had 1 victim each. So there was 3 of them, as we saw, and only 1 each. So next question, what is the distribution of race of the executionees? This one it wasn't like surprising. So basically did the same thing in terms of how I got the answer. I did a group by race and that size, and then I plotted that. And then I got the numbers just to make sure that I knew what each of these values was. So 153 white, 521 black, 129 Latino, 17 Native American, so on and so forth. But I think one of the things that we need to consider is just the distribution of race here comparison to maybe the distribution of race among the population and seeing how that differs. And I would imagine that not half of the US population is black. So I would say there's a higher percentage of black executionees than there are higher percentage of black people in America. So we don't have the data set here to take a look, and I can do a quick Google search, but for the sake of this EDA, I think this is very telling and can open up a lot of other questions, right, that we can look into. But moving forward to more advanced questions, not basic. So you have a basic question and then non-basic. I start off with the number of executionees by year. So taking 2 variables, which would be like year and race, and then year and state. And then I don't have the question here, but at some point I was like, oh, maybe this is something I want to look into. So has there been a change in execution method over time? So let's get started. Number of executionees by year. So for this one, I created a new column called execution year because we didn't have it. We just had the date. And I just extracted the year from this execution date using this datetime index .year. So once I did that, then I just made a copy of the data frame and I did another group by execution year .size. So give me a count of every record based per execution year, and then I plotted that into this here. Um, so this is telling of just an increase in executions up to 1999, and then there was a slowly a decrease, and now we have probably the lowest. I mean, we're in December already, so the lowest number of executions since 91 overall. Um, I try to go a little deeper in this and say, well, let's separate these columns and just separate them into a stacked bar chart for um, per race, right? So I did this here where I actually grouped by execution year and race, right? Once I did that and I got the counts, then I did this dot unstack, and this essentially allows me to separate the values by race, as you can see there, so that I'm able to plot this stacked bar chart. Counterintuitive, but this is what I need to do. So once I ran that code, it plotted the bar chart as such, and then you can see kind of the distribution of each year um, per race, and you can see, well, this specifically um, interesting year, and then it just kind of went back to this normal distribution between races for every year. And I use the normal distribution term here very loosely because I don't even know what that normal would be, but um, execution by year by race, similar to kind of what we had up here, but in a more, because this is not really a good picture in terms of, how do I know that this brown is bigger than this brown part here and the year before and so on and so forth. So what I did was I grouped by race and execution year, and I did a size count just to get this sort of data frame here. And then after that, I plotted it. So I did a seaborn plot, line plot, and I did this hue race. So basically, give me a line for every different race value, um, and that gives me this here. So this is, I think, a more readable chart in terms of comparing, like, well, this is what the white um, distribution is, or the white line plot looks like, and then for black and Latino and so on and so forth. So again, at some point here, like here, there were more black executionees than there were white, so that's interesting. And then we go into, it's kind of a complete opposite where there is like a steep dive the next year for black executionees, whereas the white goes up. So it would be interesting to see what happened, and it may not be something that happened that year, right? Because a lot of times it's not like you get sentenced to a death sentence and, at least from what I've read, the next year or even next 2 years you're executed. It really takes a long time um, for people to be executed. Unfortunately, we don't have that column here in terms of when they were sentenced to a death penalty and then when they were actually executed. But there would be an interesting data set to have or look for. This would be something that you can do as an additional, right? So maybe your model needs that. But for this, it's just specific EDA, and we're trying to make EDA somewhat fun, not to say like, well, just go through the motions. We're really trying to deep dive and understand, and do a quick related Google search if we need to, so we really understand what's up with Utah. Do they have what's their moniker? And that's sort of related, unrelated, but yeah, it was interesting. Now we know, right? So the next one was a number of executionees by year by state, similar fashion as race. I just separated by state instead of race here, but that's exactly what I did. And then when I plotted this, because we're saying every state give me a new line, it gets so busy. It gets, basically we have 50 lines, right? Or not 50, but 34, right? For every state, as we saw earlier, there's 34 values. So aside from this very distinct line up here, I'm not able to tell really what is happening for all these other ones, right? So I don't even know if Connecticut and South Dakota, how they differ, and if so, and how much, I guess. But what I went ahead and did was like, well, instead of looking at that, let me just look at the top ones, and we saw that it was Texas, Virginia, Oklahoma, and Florida. Those were the top four in terms of executions total, right? And then federal. The reason I added federal, even though they weren't the top four, um, I just found it interesting that they included federal in the list of states. So I created this list called list of top states, I guess, inferred. But then I created based on this. So to the data frame, I said, give me the data frame where this df copy state column is in, that value is in the list of top. If it isn't, then don't give it to me. So once I output that, you can see that you only get these states that are in this list here. So like Texas, Florida, Federal, Virginia, and then Oklahoma. Once I have that data frame, I can just plot it. And that's what it looks like right here. So you can still see Texas here, but you also see Florida, you see Oklahoma, Virginia here. So at some point one year, looks like 2001, where Oklahoma had the same number of, if not more, number of executionees than Texas, right? Um, but one thing that I saw and I noticed is this federal line. You see how it just seems to be going up as all these other ones are, trending down. Um, and so it seems like Texas, yes, it's executing less number of people, but federal is basically adding or increasing. So I'm not sure if just at the state level they're being more lenient, but at the federal level they're executing more people, or if there is a transfer between state and federal that's happening. Definitely something we can research further. But that's what I got for that answer. So I guess the answer was number of executionees by year by state. Um, I can read this whole data frame if I wanted to get that for every year. But next question, has there ever been a change in execution method over time? I did another stacked bar. So I'm not a huge fan of stacked bar charts, but I still did it. I just say that that's my excuse for doing that, but I think for this one it makes sense. It's easier to read, but anyways, go. So I basically did another group by execution year and execution method and counted the execution method for every execution year, and then did this unstack for execution method so that I can create a stacked bar chart. Once I ran that, it gave me this. So you can see that the electrocution method was pretty popular from, well, I guess based on this data, from 83, 84, and then it slowly died down. And as it was dying down, then the method of lethal injection was really probably the preferred method, which makes sense, I think, at that in terms of um, electrocution seems more cruel um, than lethal injection, even though the end result's the same. You're killing somebody, but um, this is what the data is telling us. So I thought it would be cool to share with you all. Um, so that is it for this EDA. So I will actually I can put a link to the data set, the clean data set, which really I didn't have to do any cleaning, but I'll put a link to the data set up in the comments. Please subscribe. I'll be putting out more videos on just random data sets that I'm doing, nothing traditional. And they may be, I guess, traditional, but from the randomest topics that you can think of, and just really kind of honing our EDA and taking on these random questions and trying to solve them or answer them through Google search, right? Um, but the takeaway from this all is uh, for you to do EDA, I mean, you don't need to be a PhD student on statistics. You can take one step at a time and just start slow and then go from there. So thank you so much for your time. I'm excited to look at the next data set with you all, and I'll talk to you all soon.